Hi there, and welcome to a new Fluid Painter update. Version 1.4.1 introduces several improvements. The Fluid String feature now includes a new string slack control that simulates gravity. We also have a new drop starting spline parameter, which lets us decide from which spline the drops begin. And finally, the new resolution settings allow us to separate viewport resolution from render resolution. At the end, we'll go through a practical example to see everything in action. Let's begin by looking at the string slack parameter. First, we need to merge two fluids and create strings between them. To do so, select them and click the Merge button in the Merge Fluids tool. The two fluids now act as a single one, and when they get near each other, they blend together. Now, enable the String Visibility option from the String menu to create strings between the two fluids. Strings follow the fluid spline direction. If they cross, the first fluid's direction can be reversed using the corresponding option. And now, let's see the new slack option. Slack simulates strings' gravity along the world z-axis and can be randomized to create a more realistic effect. By default, slack is not influenced by the string length, and while this may be fine for still renders, it's not very suitable for animations. For this last case, we need to use the tension control, which regulates how slack is distributed based on the string length. Let's see how it works. First, position the two objects at the distance where we want the tension to be maximum. Then, enable the tension flag and click the Set Max Tension button to automatically calculate and store the reference value. Now, as the objects move closer to each other, the slack increases. When the objects get very close, the slack decreases again. Finally, by enabling the string break option, the strings will break as soon as they reach the defined maximum tension. For a more realistic effect, the tension value can be randomized so that the strings break at slightly different thresholds, producing a less uniform and more natural result. The drop starting spline parameter is useful when you want part of the fluid to remain unaffected by the drop feature while it's enabled. In this example, we want the fluid on top of this object to have no drops, while keeping the drops at the end of the leaking strings. To do this, first enable the drop feature, then choose the spline number from which you want the drops to start. This feature is also useful when the drop is animated, since the splines without drops will remain still. Now, let's suppose we want to add splines with no drops at the bottom of the object. After drawing them, they will obviously get the drops, since drops are generated starting from the specified spline onward. Since it's not possible to manually change the spline index, one workaround is to select all the splines with drops, separate them, and then join them back to the base fluid. This way, the splines where we want the drops will receive higher index values. Finally, simply update the drop starting spline parameter to reflect the changes. When working with high-resolution fluids, the viewport frame rate can drop significantly. Thanks to the separation between viewport and render resolution, we can set the final, high resolution for the render while keeping a lower resolution in the viewport. This allows us to maintain better performance and work more smoothly, while still preserving the high-resolution fluid in the final render. And now it's time for a practical example. We're going to create some leaking fluid and drool strings inside the mouth of this tremendous dinosaur. To do that, we'll add two separate fluid sources, one attached to the lower jaw and one on the upper jaw, and then we'll merge them together to create stretching strings between the teeth. Since we want the fluid to follow the jaw movement, and the dinosaur is a rigged mesh, we'll use the sticking tool in vertex group mode. The vertex group method is more reliable than the surface to form, but it requires the rigged mesh to be in rest position. So, after adding the dinosaur mesh as the target, we can simply use the dedicated button to automatically switch its armature to rest position. Now we can create the first fluid. We'll use the water drop preset and change the color later to simulate a creature's drool. To make the drawing process easier, we'll create two separate splines, one on the right side and one on the left. Anyway, we now need to join them into a single one, since the drool strings must originate from one continuous spline. To do so, select the end vertices of the two splines and press F to create a new spline segment connecting them. Now we can add a few more leaking splines to make everything feel more organic and believable. We'll also use the new drop starting spline parameter to remove the drop from the first spline. Setting it to 2 ensures drops are generated starting from the second spline and the ones following. Once the first fluid is painted, we add the second one to the upper jaw, following the same steps. Since we don't need any additional splines there, we can just disable the drop feature entirely. Before proceeding with the fluid sticking, make sure the Keep Fluid Properties flag is enabled. Otherwise, we won't be able to merge the two fluids later. Then select both fluids and click the Stick Fluid to Object button to attach them to the target mesh. Switch back to pose position, move the animation, and you'll see that the fluids follow the jaw movements. However, you may notice that the fluids look jagged. This happens because when the fluid curve is converted to a mesh, it has a much higher vertex density than the target mesh, and the vertex weights are not transferred correctly. To fix this, simply lower the spline resolution before stitching the fluid. Now, we can finally merge the two fluids. To do this, select both of them and click the Merge button. Keep in mind that the first fluid you select will inherit the properties of the second one. After that, open the String menu, enable String Visibility, and set an initial slack. Then, set the animation to the point where the jaw is fully open, enable the String Tension flag, and click the Set Max Tension button to automatically calculate the maximum tension value. Once that's done, adjust the parameters to achieve the desired effect. Remember that strings are generated from the spline number specified in string spline fluid 1 and 2. In this case, they start from the first spline of each fluid, so we can leave it at the default setting. One last tip: when working with animated fluids, special attention must be given to the resolution. If it's too low, it can result in a jittery effect. To fix this, you need to increase the resolution until the fluid looks more stable. Anyway, a high resolution can significantly lower the frame rate and make it harder to work. And this is where the new render resolution parameter comes into play. When activated, the render resolution will be used for the final render, while the viewport resolution can be lowered to achieve a better frame rate while working. And that's it. For more details on the new features, please consult the Fluid Painter documentation. Thanks for watching.